One of the files I uploaded was actually this project earlier on. So what I want to do now is just go over it quickly for you guys to have a look at. So if you just open Grasshopper, just want to demonstrate it. I need to find the file first, don't know where I've saved it. Okay, so file open. So I just want to take you through the different stages of how the spatial diagram is generated and tested. I'm not going to kind of script it all from the beginning because that will take time, but I'll break it down into very clear kind of segments, right? It'll take some time to load because it's a bit heavy. But after this, I wanna go through a scripting exercise with you guys where you can actually build something parallel to what I'm doing here. Okay, so let me just take that. Just move this here. So I think I've uploaded this already for you guys to have a look. So you can download them. Just 1 second. So very simple. Again, this is another thing that you can do, right? You can start off with geometry that you want to react to. Yeah. So don't think that you have to generate things from scratch completely. But let's say this is our floor plate arrangement. By the way, this wasn't my final project at the end. This was just something I developed and then further developed. So this was a stage where it was kind of underdeveloped. But it's good to demonstrate. So very simple. I have the different floor levels, and I have points, right? So you can do this in a lot of ways. If you divide the surface, you can extract the points here. So first things first, here is calculating the field conditions. Yeah. So if I take each of these surfaces, yeah, and then I can develop. So I took a vector. Ooh, that's not right. What's happened there? Yeah, so you can see here. So let's say this is my floor plate, right? And this is my field condition for light. So what I've done here simply is just take a vector from the north and then calculated where I receive most light on these floor plates. Yeah. So you can see here, some of my floor plates don't receive as much light as there. So I'm calculating the different conditions that are available to me. So this is light, proximity to circulation. So this is how close certain things are to circulation. Two vertical circulation kind of elements at that point. So you can see the circles here were bigger than the circles in the middle. Yeah. And then the other one, I calculated the noise. There was the main road here and I think a bridge. So you can see these values mean the bigger the circle here means I have less value. I have less noise. The smaller the circle means I have more noise. And all this is calculated through numbers, right? So you can see here, these are the numbers that I get. So it's taken every point. The circles here are just to visualize the numbers at those specific point. Yeah, but every point, simply put, every point here has a value associated to it in terms of the noise. So these are the numbers. proximity circulation light. Don't remember what this is, but this was okay. So this was the noise coming from the bridge, and this was the noise coming from the road. Yeah. So four different things I'm considering for this project, right? Here. Now combining them together, I get a field that you can see has a lot of variation, right? So you can see this is bigger because this one because it has more light. At the same time, this is the biggest one because it has most light. It's closer to the circulation and it has less noise. So you can see if I just simply add up all these numbers and visualize them again, I get this visualization of how the conditions are on my site. Yeah? But then I have 3 different programs, right? So at that point, I was developing, I think, a study commons. Yeah. So I looked at 3 different space types. So a lecture kind of space program, cellular spaces, and open spaces. So you have to think about what are the requirements of each of these spaces. So here you can see by taking all these conditions, I map them to the scalar field. So the scalar field is just a word for fields here. So let's say a noise is something important I need to avoid for lecture theaters. So I'll take this number, I will invert it. Yeah. So if something's more important, I'll multiply it by 2. If it's less important, I'll just multiply it by 0 and then add the numbers again so I can get a field specific for where my lecture theater should go. Right? So I hope that's making sense. So each of these fields, so you can see here with the cellular, based on the field generating logic here, you can see that it will better for this type of space to go where the biggest circles are, but for the lecture theater, it's better for them to go where the biggest circles are. Yeah. And the same here with open spaces. So they all have their own unique field conditions in terms of where they should go. And then this part here is just about prioritizing certain things. So this is the slider. So you can see here, I developed this just kind of this 3-way slider where I can actually change it. So let me turn the views on again. So let me look for that point. Is it this? No. Is it that? No. Don't know where the point's gone. Oh, here it is. Okay, it's this one. So if I bake this, we'll just wait for it because it takes time to process. You can see here on the bottom, it's actually generating the different spaces, right? So it's placing the blue ones first, then the green ones second, so they just came up, and then lastly the red ones. Let's give that 1 second. Come on. There we are. So here, so this is how the different spaces are placed. Yeah, based on their preferred positions based on the field conditions. Yeah, what that inside offers. And basically, what this slider does, if I want to change the proportion, if I want more lecture space. I didn't link the point again. Okay, so if you just have a look at this, there's more green kind of spaces, but once I move it, it's at 1 point. Just 1 second. So. something wrong. No, this is not the point. Where did I put it? This. Chris's point. Anyway, it's been a while, so I need to figure out what's going on here. But the idea is you set these proportions, and then this part of the script here basically just places things based on priority, and these are just Python scripts. So if you double click here, you can see the different scripts. I'm not showing you this because I want you to mimic it. I'm just showing you to show that you can think about the theory in different ways, and this is one of the ways I interpreted theory. Yeah. So yeah. So that's just the demo. Is there any questions about this demo? You want to understand something particular? I want to ask about how to do something in particular. Otherwise, I'll just jump to the next demo. No? Has anyone got any questions?
What's the engine bit that you got there?
This one here.
Yeah.
Yes. So okay. So here. So this here. Let me just close this because I don't know why it's doing something funny. Let me open it again. So let's say you have a way where it's not working anymore. I'll figure that out. But anyway, so here I get the different fields, right? Because I haven't turned this on. So I get the different fields for each of the program type that I want. Yeah. So this is the overall field. I just add them all, and this was me mapping them to what's important for the specific space. This one here basically takes the value of the proportion or priority that I want here. And just based on this, it'll calculate how much of the lecture spaces I need. So place those first. How much of the cellular spaces? So place these second and these third. So this is where the geometry actually gets generated at the end. Yeah. So this is prioritizing. This is actually placing all the different spaces where I need them. You can see one there, but yeah. But there's other ways you can think about this theory, right? And how you want to place them. This is not just the only way, but I've uploaded this to the Grasshopper library, so you guys can unpick it when you have a chance. Okay.